Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 2, Using Double Angle Identities. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we derived the double angle identities. Here they are. In this video, we apply these identities to evaluate trig functions. For example, suppose cosine of theta is equal to 3/5 and sine of theta is less than 0. Find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. In what quadrant is 2 theta? Now, it's worth mentioning that we don't directly have double angle formulas for the reciprocal functions, cosecant, secant, and cotangent. But as you can imagine, we could just find the double angle values for sine, cosine, and tangent and reciprocate them. So we don't need 3 more double angle identities. But let's do this one. Now, clearly we will use the double angle identities because all of our angles have 2 in front of them. However, to use them, we need the values of sine of theta and tangent of theta. We were given cosine of theta. That's because our double angle identities require sine, cosine, and eventually tangent. So first, let's find the value of sine. Let's think about an efficient way to do this. Now, we know the value of cosine is 3/5, and we want to know the value of sine. A Pythagorean identity connects them, sine squared theta plus cosine squared theta is equal to 1. So since we know cosine of theta is 3/5, we can simply substitute 3/5 for the cosine theta. Don't forget there was a square on it. Square the 3/5 to get 9/25. Subtract 9/25 from both sides of the equation. We're solving for sine of theta. Let's do the arithmetic. Common denominator is 25 over 25. Subtract to get 16 over 25. And then to isolate the sign, we would simply take the square root of both sides. Don't forget the plus minus. And conveniently in this problem, the square root of this fraction is just 4/5. So sine of theta is plus or minus 4/5. However, we were told that sine of theta was less than 0. So for this problem, sine of theta is negative 4/5. Let's go ahead and get the value of tangent of theta. Now that we know cosine of theta and sine of theta, we can find tangent of theta using a quotient identity. Tangent of theta equals sine of theta over cosine of theta. Upon substituting the values, we get tangent of theta equals negative 4/5 over 3/5. When you're dividing fractions, you multiply by the reciprocal. So we have negative 4/5 times 5/3, but the 5's cancel, and we get tangent of theta equals negative 4/3. Now, we haven't answered the question yet. We're just priming the problem. We're prepping it to answer. Now we can find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Remember, sine of theta is negative 4/5 and tangent of theta is negative 4/3, and we were given cosine of theta. So starting with sine of 2 theta, sine double angle identity says that's equals to 2 sine theta cosine theta. But we know both of those values, so substituting them gives us 2 times negative 4/5 times 3/5, which is just negative 24/5. So there's the value of sine of 2 theta. For cosine of 2 theta, we're going to use cosine squared theta minus sine squared theta. Although we could use any of the 3 cosine double angle identities, we should get the same answer. Well, that becomes 3/5 squared minus negative 4/5 squared. 3/5 squared is 16/25. No, it's not. 3/5 squared is 9/25. Negative 4/5 squared is 16/25. So 9/25 minus 16/25 is negative 7/25. There's cosine of 2 theta. For tangent of 2 theta, we can use the double angle formula, or identity, 2 tangent theta over 1 minus tangent squared theta. But tangent was just negative 4/3. So substituting negative 4/3 for all the tangent thetas gives us this expression. The numerator ends up being negative 8/3. The denominator is 1 minus 16/9, which is negative 7/9. That doesn't sound right. That is correct. 1 minus 16/9 is negative 7/9. And then if we divide by multiplying by the reciprocal and clean it up, we end up getting 24/7. I encourage you to verify that that is the final result. Now, alternatively, we could have said tangent of 2 theta equals sine 2 theta over cosine 2 theta, and just taken the ratio of the first two answers, we still would have gotten 24/7. Now, as for the quadrant of 2 theta, observe that sine of 2 theta was negative 24/25, and cosine of 2 theta was negative 7/25. Since sine and cosine are both negative, 2 theta is in quadrant 3. Now you try. Pause the video and work the following. Suppose sine of theta is equal to 5/13 and cosine of theta is less than 0. Find the values of sine 2 theta, cosine 2 theta, and secant 2 theta. And what quadrant is 2 theta? Pause the video, give it a try. All right, if you haven't paused the video yet, this is your last chance. Solutions in 3, 2, and 1. It flows like the previous one. The main difference is I asked you for secant of 2 theta, so we just reciprocate 2 theta to get secant of 2 theta. You can pause the video and read all the details, and I hope you got the right answer.